let me now switch modes a little bit, and my style is to go to the data side of it a little bit. And so I will be going through a lot of information and data. And I've given you a bit of background of why I'm interested in this. I was confused by the claims that were out there, so I dug into it. And I have dug in pretty deep, and I've got all my work is available on our website, and you can go through it and see everything I've done. So first of all, let's just remember what carbon dioxide is. There's two relevant properties. It's a creator of food and oxygen, food for plants and oxygen that's released, and it's a greenhouse gas which says it has a heating effect. The importance of carbon dioxide and water equals to plants, so the relationship of carbon dioxide and water to plants is very similar to oxygen and water to humans. They're both very important to life. So I just wanted you to keep that in mind as I move forward. There are some comments earlier that you made about things starting to shift and the emphasis and concerns of CO2 and climate crisis are decreasing a bit. Well, we know of one fellow who certainly did that. That doesn't mean it's right or wrong, but Bill Gates has decided to shift his funding away from climate crisis and net zero and back to public health. And really why we're here today is I'm hoping our government can shift spending money on trying to reduce its minimal CO2 and instead use that taxpayers' money on things that make a direct impact to people of Jersey, health, etc. So that's the whole purpose of why I'm here. I served on the Public Accounts Committee. I know the value for money. When I saw this, I just decided it's time. I couldn't just sit back and do nothing. So I'm hoping, whether we agree on the impact of CO2 and soil, etc., it's really the issue of where can we best spend our money, I think is very important. So what I'm going to do in my talk, I'm going through, there's 7 main points through my research and looking at this that I'll go through. Climate change and global warming is normal, and I think anybody who follows various ice ages would agree with that, but I've got a few slides on that. I'm also going to share with you that over the history of mankind, warmer temperatures are in balance better than cold. So this fear of heating and warming up, put it in context. CO2 levels have always changed throughout the world's history. And more CO2, I'm going to share with you why I believe it's good and not bad, and I'll have the data and we can look at that. We are not in a CO2-driven climate crisis. And I'll show you the history of all of the items that are claimed to be out there that are increasing or not, and I'll show you the data behind it. The science is not settled. Science is never settled. And there's a claim that there's 99% of scientists say that. I'll show you some information. I'll show you also some very strong scientists that disagree with that. And I was just down in Washington, D.C. in a conference about this very subject. And also I'll close off by sharing with you some of the negative implications of pursuing net zero. It's not all positive, besides costs. Now I recognize these results are contrary to what you think. All I ask is that you try and have a bit of an open mind, listen through as best you can, and then we can discuss these things after. That's my only request. I get zero funding for this. I do it purely out of my belief that in researching this, that something wasn't quite right. So the first point, climate change. As you can see in this graph of the history of climate over the history of the Earth, it's always been changing. And through most of the time, the climate of the world was higher than it is today. And there's a few cartoons thrown in here. I want to thank my wife for that because she said you'll bore people with those graphs and stuff. So you're going to see this throughout, but you'll be able to easily get the message behind it. It captures your attention. And for example, this first one, natural cycles have always shaped our climate. Warming is so far is moderate and manageable, and I'll show you the information on the actual changes in climate. So the second point, mankind has thrived historically under warmer temperatures rather than colder temperatures. And when you look back at the temperatures of mankind's history in the Earth and what the average temperatures were, you'll see this. For example, during the warm Bronze Age, man survived, and then nearly had very difficult times in the Greek Dark Ages when temperatures dropped. During the Roman warm periods, when we were growing grapes in Scotland, mankind survived and did very well, and then was followed by the Dark Ages, and temperatures were much lower then. The medieval warm period saw civilization advance with positive living conditions. That was followed by the Little Ice Age, and times were very tough. These warm periods, historically, when mankind thrived, were all higher by about 0.5 degree to 2 degrees on average than what we're facing today. So I just wanted you to stop, reflect, and understand. All of this data is supported, and I can reference, and you can see that. Another element of warm versus cold is the simple fact that about 4 to 5 times more deaths occur cold-related than warm-related. And I think that should be fairly obvious to you, but I just wanted to stress that point. Warm is better than cold. So now let's look at CO2 levels. CO2 levels have been changing throughout the history of mankind and the history of the world. This data is very conclusive, that shows rapid changes and increases and decreases in CO2. Today's level, a couple points. First of all, at the time of dinosaurs, for example, the CO2 level was 2,800 parts per million. When life began on Earth, it was 8,000 parts per million. Today's CO2 is about 420 parts per million. Concentrations of up to 1,000 parts per million are common in classrooms. And if we didn't have the door open and I had a meter, it would probably be up to about 1,000, because we breathe out CO2. So I just wanted to share that with you. And CO2 emissions into the Earth occur for many reasons. The volcanic eruption made a huge impact. It spewed out this recent one. It's just an example. There's lots of things happening in nature that have an impact on the atmosphere and the world. This particular volcano erupted under the water, and it spewed out massive amounts of water vapor into the air. Water vapor is a greenhouse gas, and it covered the entire Earth with that. It was a big thing, and it may have had an effect with that increased water in the atmosphere and CO2 in the atmosphere just from that one event of impacting temperature. There's many, many things that impact temperature. Another element of CO2 that's so important is the benefit to growing plants. Greenhouse gases, first of all, they keep the Earth warm. They absorb heat and radiate it back. If we didn't have that, we wouldn't exist on this world without greenhouse gases, and CO2 is one of those. But this other element I want to stress is that when CO2 increases, plants thrive. That's their source of fuel, of food and fuel. They become larger, able to absorb more CO2. And a standard practice in agricultural and greenhouses is to increase the level of CO2 to promote additional growth. And there's an example at the bottom. The only thing different in those tree growths was the amount of CO2. As they increased the CO2, they looked, and the results of growth of the plants was significantly improved. Nothing else changed. Right now, when you look at the time of the track of CO2 over time, we're in what is called a CO2 famine. It's gone up from about 180 before we started burning coal and increasing it. If it had continued to decrease at the rate it was going, at 150 parts per million, plants could not live. CO2 was declining, and if it kept going, plants would not live, and then we'd be finished. Mankind did increase that CO2 level through burning coal and hydrocarbons, etc., and it went up to about 420. The optimum level for plant growth is significantly higher, and historically we've had much higher levels. The other thing that's very interesting is NASA has taken satellite photos of the Earth. And what we're seeing is significant greening of the Earth from 1982 to 2015. And a large amount of that greening is occurring at the deserts and at the edge of the deserts, because with more CO2, the plants need less water. And the reason for that is they don't have to open their pore spaces as wide. To get the CO2 they need to live, and therefore they don't, the water doesn't escape. And so they can actually live with less water. And this is well demonstrated. Crop yields. If you look at the crop yields and the improvement, it's very, very significant. And that's from CO2, added CO2 around the world. So if you worry about feeding the world, there's better and higher yields are happening now because CO2 levels are higher than they were historically when it's lower. So this, if you're concerned about this, this is a very important part of it. So here's a little summary slide. CO2 is plant food. It's essential for life. And it's a natural part of a healthy planet. So let's now look a little bit more. What is, if CO2 isn't driving climate, what is? Well, let's start with the sun. I think we all know the sun has a tremendous effect. Day and night, seasons, we all know the sun is a huge driver of climate. No surprise there. NASA states that the Earth's orbit, and these are called Milankovitch cycles, is the likely cause of major climate changes, including the ice ages, which is dramatic changes from cold to warm periods. Presently, right now, we're in a warm period and we're recovering from the last ice age. So when you hear about record temperatures, etc., you need to remember these are temperatures from when it was much lower and now we're rising. So you're going to get record temperatures if you're starting from a low, and it'll keep increasing until we hit another ice age. And that will happen as it has in the past. There's all kinds of these ice ages that keep repeating themselves. There's other factors that impact climate. Ocean currents have a major impact on temperatures. Clouds have a huge impact. They reflect the sun as it's coming in to start with. A 1% change in cloud cover can have the same effect as doubling CO2 levels. Greenhouse gases have an effect, absolutely. And water vapor is 90% of that. That's why we're able to live and keep going. Human permanent settlements, the urban heat island effect, is another factor. And there are other factors. The message here is climate is very complex. Mankind's contribution of CO2 makes a very minor impact on this climate. And I'll show how that works. So let's look at CO2 and how does it fit in the atmosphere. The greenhouse gas takes up 0.8% of the total atmosphere of gas. CO2 represents 5% of that. You do your math, and CO2 represents 0.04% of the total atmosphere in the Earth. Mankind's contribution to the CO2 level is only 0.0011% of that. When you look at 0.04, that's like a couple bathtubs of water in a huge swimming pool. Just to put it in context, it's a very small amount. Then you look at Jersey's total amount of human-derived CO2. If you're starting for those levels and you look at Jersey, it's less than a drop in the ocean. Just keep that in mind. So let's look at the correlation then. If CO2 is driving climate, we should see a match between CO2 and climate. And you mentioned this as well, Adrian. But if you look at it over geologic history, CO2 and its changes do not match climate changes and temperature changes. If you look in particular at around 150 years, CO2 is shooting up and spiking, and climate temperature is dropping. So there is no correlation between CO2 and climate change. Let's look a little closer because fortunately with glaciers, they capture, you can drill cores into the glacier and get trapped gas bubbles. So you can get a very good reading at the CO2 and the temperature. And Al Gore saw this correlation and he got quite excited and said, there's a correlation between CO2 and climate, and therefore this whole thing kicked off. But what he didn't do is look closely at the data. If you look closely at the data, you see that CO2 does not start and then temperature, it's the opposite. CO2 lags temperature changes. How can it cause temperature changes if it follows? And the data is very clear on this. And if you think about it, the ocean warms and it emits gas. This is Henry's law. So warming water, warming fluids contain less gas. And you can do this experiment yourself. I encourage you, take a glass of some pop or soda pop or something and put half of the glass in your fridge and half of it leave on your table. And then come back an hour or two later and have a sip out of it. And you'll find that the warm cup is much more fizzy and bubbly than the cold one. The ocean, as it warms, releases CO2. It's a fundamental principle of Henry's law. Now, there is a good correlation, however, between sun activity and temperature, which shouldn't surprise us when we started, and we know the sun's the biggest impact, and sure enough, there's a very good correlation. But then when you plot CO2 levels on top of that, there's no correlation. Here's our summary slide. So the past has shown us that more CO2 does not mean runaway temperatures. There's no correlation between higher CO2 and higher temperatures throughout geologic time. Let's dig into this a little bit more, this heating effect. So the sun's radiation, I'll take a little bit of time here because it's important. So the sun is beaming out heat, and it's coming in and it hits the surface of the earth. Some of it's reflected by clouds, some of it penetrates, then it's bounced back, and then that's when the greenhouse gases come into effect. They'll capture this heat that's coming out, they'll get excited and they'll emit energy back, and that's what keeps us warm. But here's a couple things to recognize. With added CO2, the absorption capacity of CO2 reduces logarithmically. This is a proven fact. It's like a sponge of water. When you fill it up, as you put more and more water in, it has less ability to contain more water in it. CO2 in the atmosphere has the exact same effect, and this has been proven experimentally and theoretically. We're already at the level, getting close to the level that as we add more CO2 into the atmosphere, its ability to act as a heater and keep the heat in reduces logarithmically. So this is, you're shaking your head, but afterwards I'll give you the data and show you the experiments and the references for this. But I don't think that the scientists that are pushing the climate crisis would disagree with this. And the professors will show that. I'll show you the reports. Here's Max Planck, who did the technical work on this. The spectrum of radiation from warm bodies. He shows that the impact of doubling CO2 from 400 parts per million to 800 parts per million is only 0.71 degrees centigrade. And then if you double it again, because remember, it's an exponential effect, you only, from 800 to 1600, it only gets 0.35 degrees. In other words, if you go from where we're at now, just over 400 parts per million, and go to 1600 parts per million, which will take quite a long time, the impact is only 1 degree centigrade. And this, I will show you the data and will be pleased to, you can get that and test it. This is the science, and I'm a scientist, and that's why I'm here today. So here's our summary. Bottom line, a small part, CO2 plays with limited warming effect. And it's diminishing as you add more because the nature of the exponential decrease over increased amount. So we've also heard a lot about the models. Well, the models predict things, so therefore it must be right. Adrian already commented about the nature of this, and it's not possible to model it. It's very, very difficult to. And sure enough, when you look at the predictions of the models, and then you compare it to the actual, there's a big bust. So the point is the models are having a tough time predicting future climate, and yet governments are relying on these models to put in various programs, etc. So here's our summary. Climate models tend to overstate warming, observations don't. Real world data matters more than model guesswork. Observations, not models. Let's look at the data. So in summary here, the biggest drivers of climate are the sun, oceans, wind, and water vapor, clouds, water in the atmosphere. We've all known that. You've experienced it your entire lives. The sun provides the energy, the oceans and the winds move it around. They have driven our climate for millions of years, and they continue today. It's not CO2 that's driving it. So now I'd like to go into the crisis aspect of it, because every day the media scares us to death about increased, you'll see about a hurricane or whatever, it hits the headlines immediately. So let's look at the actual data, the scientific data of climate changes. The Earth has been warming since the late 19th century by about 1.2 to 1.5 degrees centigrade since pre-industry times, recovering a little from the last ice age. So this is not unusual. Between every ice age there's a recovery, then there's been another ice age. Over the last 540 million years, Earth's average temperature has often hovered around 19 to 25 degrees centigrade, far warmer than today, of about 16 C. During those times, we had thriving ecosystems. All of the different kinds of plants evolved and developed, etc. So today, a degree or two of variability would fit within the natural cycles. So we shouldn't be afraid and scared. Let's look at the actual crises. This one talks about heat wave index and the problems with heat waves. But when you actually look at the data, and you see where it is, and by the way, every one of these charts I have references and data for. You'll see that the spikes of heat waves were in the past, in the dirty 30s. In North America, we heard a lot about this. They had a lot of problems with farming, for example, in Saskatchewan, where my grandparents came from. So the spike was not now, it was in the past. Let's look at droughts and flooding. We hear about how terrible that is now. But when you look at the data, historically over time, these things always do happen, but the amount of it hasn't changed. So we hear the media tells you about these things, but when you dig in and look at the data, it shows that there's not the kind of variation. You know, the expression, shit happens. Well, these things do happen. Hurricanes, tornadoes, the graphs when the data show the same thing. It's not increasing from what you hear about. Tornadoes, you could even argue, are going down. And then you can see on the one chart the increased CO2 levels and what's happening. Forest fires. Forest fires are not going up. The impact of forest fires, because of all the population, is a bigger issue, but the actual number of forest fires, here's the data in the US, is not going up. All of this data is available for you. Now let's look about sea level. This is all nice, all those things are nice, but what about Jersey? And I think I heard somebody say, we're going to be flooded in a little while, you know, and all this is going to happen. I'm going to share you data that may help you relax a little bit. This isn't going to happen to Jersey. This is not what's going on. So how does sea level change to start with? Sea level changes for two main reasons. One is with tectonics, you can open up huger basins and big holes which take a lot of sea and then it would drop. And the other is ice with the glaciers. Those are the two biggest impacts of changing sea levels. As the temperature gets colder and all the water is turned into ice and you get these huge ice shields on continents, sea level drops. When it melts, sea level rises. That's the biggest impact. The other thing to remember is, and recall, is that when you have ice in water, melting it makes no difference to sea level. You can have a glass of water, fill it with ice, and watch what happens when it melts, the same level. It's only the ice that's on the continents when it melts changes sea level. Most of the ice on the glaciers in the North American continents have already melted. So yes, there's still more in Greenland, and it's going to increase sea level when it melts, but a much less degree than what we've seen historically. Here's a graph that just shows the rate of sea level rise relative to ice and when it happens. The most rapid increase level is when you've got all that glaciers on land that are melting, the water's running off, and it's going into the ocean, it's rising. We're sitting at the upper right end curve. There's much less ice on glaciers on continental lands than there were in the past, and the rate of sea level rise is much less. We know that sea levels changed. We see it right here in Jersey. So bring it home a little bit. We know that this because you can go and see the dolmens. And when these dolmens were built 7,000 years ago, sea level was much lower and Jersey was connected to France. And people were just walking along and going straight across. The dolmens we see in Jersey are the same dolmens, similar style, that you see when you go across into France and wander around there, just east of here. And I've seen that. I've gone and seen these. The other element of evidence that shows that sea levels were much different in Jersey is if you go to the beach in St. Juan's and the tide's out, and you'll see the remains of a petrified forest. There was a forest there at one time in the past when sea level was much lower. And it's risen, and that's why we no longer grow trees in the middle of the beach there. So here's what sea level rise looks like. A picture of New York City, 1898 and 2017. This is the scary sea level rise that's going to flood us all. The thing I notice is difference is our cameras are better. We got color instead of black and white. So sea level rise, the facts. The evidence shows sea level rise is real, but it's slow, stable, and manageable. You should be able to sleep at night. Oh, by the way, there's some data there, actual data from Jersey, so you can see what's happening. The scale is small, so there's a little bit of a spike that occurred, and it's gone back, and it's pretty slow. But you'd know this walking around. You've lived here long enough to notice how much difference you've actually experienced. So why the scare? Be careful with the media and reporting. The two pictures on the left show weather maps. And if you look at the numbers are very similar. And then you look at the colors on the maps. On the one it's in green, there wasn't a CO2 scare going on. This other, it's in red, and there's a whole bunch of fear coming out with the same data at a different time. So be very careful. And we've seen that in the past when there was concern that we were going to have another ice age. Magazines had all kinds of headlines saying, oh, we're going to freeze, beware. And then recently you'll see the same magazines, global warming, beware. Media loves fear. Please relax. Here's another thing to watch out for, scale. If you look on the left, this is the scale of the average temperature in Jersey. It goes in the winter down as low as 0, summer up to 30. There's a typical range that Jersey experiences. And yet what we see is the graph on the right, where they change the scale and they make a big deal out of that little bit of increase, and then to add emphasis, they change the colors. They love to put red as a scare. Same data, just puts it in context of what's happening in there. Public predictions about environmental climate catastrophes are often more dramatic than what has actually happened. There's been a whole series. There was a study that looked at 100 doomsday predictions made by environmentalists over the past 50 years. 2/3 of these predictions, when you look at it, the time has run out, and yet all of them have been turned wrong. The alarmist predictions argue for a whole bunch of things that cost us a lot of money. I suggest to our government policy should be based on evidence rather than worst case scenarios that are not showing up. So there's been a lot of effort to reduce CO2. We've had all these conferences, treaties, Kyoto Treaty, etc. So what has actually happened in the world? With all this stuff going on, and running around and doing it, spending all this money, what has happened with the actual CO2 levels in the world? They've continued to go up. As the earth warms, the oceans release CO2, as they do. That's a fact, as I mentioned earlier. And mankind is adding significant amounts. In the dates here, mankind certainly was burning fossil fuels, and it's increasing over that time period. But with all these initiatives, the point of this slide is, with everything that's been going on, including China, who's burning more and more coal, in India, this isn't going to stop. And the levels are going on like that. This is just data that's out there for you. So are we experiencing a climate crisis? And I'm suggesting to you that no, there isn't a climate crisis any more or less than there has historically. Droughts? No, there is no increase in droughts. Forest fires, I've shown you that one. Flooding, the answer is no. Hurricanes, no. The data is there. Just go and Google it and look at over the historical data and you can find that yourself. And then there's a question in the comment, well, I believe the scientists. 99.999% of them say there's a crisis, so there must be. You know, when Columbus sailed across the Atlantic to find North America, I don't think he was doing that based on consensus. So there is consensus among scientists that temperatures have been increasing, and I agree with that. Climate is changing. It always has. Mankind has definitely increased the CO2 levels. I completely agree with that. However, where the disagreement occurs is regarding the degree to which mankind's CO2 emissions impact temperatures, or whether this is actually causing a climate crisis. So here's a list of scientists. There's many more, and I encourage you to Google and check these people out. These are very highly skilled, creditable scientists. They disagree with the climate crisis scenario. I've personally met 3 or 4 of these individuals. There was also the World Climate Declaration, signed by more than 2,000 professionals, declaring those. I'll let you read it. It's pretty much what my talk is. So there are a lot of scientists there, and then you have to ask yourself, why were these scientists making these claims? If you dig into it, you'll find there's a lot of money behind this. So I'll come to that. So there are negative implications in pursuing this. I mentioned that. You've got higher costs, lower reliability, environmental concerns of renewable energy options are real. It's not all just a bed of roses out there. Germany's situation, I think we're all familiar with the problems Germany's having as they went full into solar and wind generation under the claim that this is cheaper energy. Forget about all the subsidies and everything else. The reality in Germany is they're struggling with the highest costs and highest intermittent energy in all of Europe there. For periods when solar and wind output fell to very low levels, Germany had to go to alternative methods. They had to have backup. As soon as you double down and back up, it's obviously going to cost you more because it's not a steady, reliable supply. Britain has also invested significantly into offshore, resulting in very high energy costs. Right now, Britain has some of the highest costs in Europe. You're shaking your head, but you just look at the data of energy costs in Europe. I have another slide coming up, I'll show you. During the recent heat wave that we experienced, Britain paid, and these are facts, Britain paid around 1,400 megawatts, roughly 15 to 20 times the wholesale price for importing emergency electricity from Europe. Their system was oversaturated, they didn't have a reliable backup, and they had to purchase it. Those costs go back to the consumer. These are recent events that just happened. So here's UK's energy price. What is actually out there? I wish it was the blue, but it's not. It's the brown colors. You'll see the impact. Natural gas remains relatively inexpensive as a fuel. However, households pay considerably more for this wholesale cost because network charges, supplies, etc. Electricity also carries a range of additional costs affecting relative prices and heating. But the bottom line here is that one big thing the UK did is they moved to offshore wind, and here's what the prices of what they're actually paying. This is a reality of a person's wallet. There are other concerns with wind farms and solar panels. It uses up a large amount of land. In Jersey, we have a policy you can't even build a new building because we want to preserve our green space. And yet they're putting on solar panels that are occupying huge chunks of land. This goes against the whole premise in the first place. And that's just Jersey. But if you look at it in a macro extent, wind farms, solar panels use up a lot of land. Offshore wind farms have a lot of issues as well with marine life, birds, etc. So there's other concerns that are out there. If you look at batteries, and you're worried about third world people, etc., Where do you think those batteries and lithium mines are coming from? Did you dig in to understand the amount of child labor that's going into that to get the batteries to support this? And then what do you do and clean up and dispose of these wind farms? The blades, what do you do? And excuse me if I'm getting my terminology, I'm wrong on some of these things, but I think the point of this is to understand what I'm trying to say. So what do you do with these turbine blades? What do we do with the solar panels? What do we do with disposing of the batteries? These are real problems. There are problems as well on the other side. There's always going to be some problems, that's the reality, but these are big issues. So here's our summary here. What I believe we should be doing is focusing on solutions that improve lives today and build a better tomorrow. That's real climate leadership. Trying to reduce the CO2 from our 0.001% to some target, which I don't even know is achievable or even understood, versus taking those investments and money, our money, and putting it into things that are real and make a direct impact on the people of Jersey. That's what I'm trying to address with this conference and why I'm trying to address our government. Here's just a summary. Net zero by 2050 is pointless. It's not going to happen. The changes, you've seen what's happening globally. Net zero, it's unachievable. It's unfair. What right have we to go to the third world and say, you can't produce cheaper energy, coal and gas, even though we built our economies on it? No, you have to go to higher costs. Well, meanwhile, we benefit from it. That's just not fair to these people. So I'm suggesting the challenges we face, including climate, including the fact that it gets hotter, all these things, we should deal with it. But the answer isn't in dealing with it by trying to reduce CO2. If we want to take some money, we can do things. If there's ways to help our soils with more CO2 in it, let's find ways to do that. By adding it to the soil directly. If carbon is important to the earth soil, which it is, there's things we can do. But let's do things that are real, measurable, and concrete. So those are the points I hope I covered. At least you understand where I'm coming from. They are contrary to what you read in the media. They are contrary to the 90-some% or whatever the latest number is, what scientists are said. But if you dig into that, and I've got information, many of the scientists I listed quit the IPCC because they're concerned with what was going on. And I'll let you even talk to those people if you like. But dig in yourself. All the stuff I've done is on our website. You can look at in detail all of the slides, all the presentation material, all of the references is clearly there, or I'd be pleased to talk to you at any time. Okay? So that's my view. Clearly there are other views, and I respect that. What I'd really like is I don't want you to buy into what I'm saying because I must have some bias. I've been told I'm an oil person, so I shouldn't even be here. That's not fair for me to be here. I'm conflicted. What I'm asking for is let's have a proper debate. I will bring in non-oil people, scientists, and you can bring in your scientists, and let's have a debate, and let's make that available for all of the people of Jersey. This is costing us way too much money and time just to put our head in the sand and ignore it. We need to do something positive about it. And I think the next step is a debate, and I've asked Deputy Renoff many times for the debate. He tells me no, he knows everything about it. There's no way. But I think we should. Okay, that's my 2 bits. I'll now open it to questions.